So if you would, go ahead and take these out, this page out that we looked at last time. And we went around the room, we went around the school and measured some things. And I wanted to talk about what your sentences were, because I did ask you to write 3 sentences, right? You had to write a sentence that interpreted the slope in context. You had to write a sentence that compared the middle stairwell to stairwell 1. And then you had to write a sentence that kind of, does Stonewall's wheelchair ramp comply with state regulations? Okay, yes or no, and how do you know that? So let's start with the slope in context, okay? So who wants to read their sentence? And let's see if you agree. What did we agree the slope was again? 0.07, is that right? That sounds familiar to me. Okay, so 0.07 we decided was the slope, okay? And so we did what with that number? We changed it to, I think, a fraction, didn't we? Okay, and what did we say it was? 7/100ths. Okay, good. And then we need to interpret that, okay? Because we use, what unit of measure did we use? Centimeters, okay? So we use centimeters. All right, so when I talk about interpreting the slope in context, I want you to use not only the number 7 and 100, but I want you to use the units, okay? So, and because the slope is a ratio, it's a fraction, I'm looking for you to say, for every amount of this, this happens. It's like a ratio. We're going to say, you know, that kind of, we're going to explain it that way. So anyone want to volunteer their sentence? Zara, go ahead. That's perfect. I love that. Notice she used long and height. Okay, she used those are key words, because when we talk about slope, we're talking about the rise over the run, and we are talking about the vertical distance over the horizontal distance. So we have the change in our y, which means how far up or down, or as Zara said, the height. And then we talk about the run, it's the change in x, which is a horizontal distance, or how long it is. So for every 7 centimeters of height, it has to be 100 centimeters long. That's perfect. Anybody have a different sentence? Different sentence? Nobody? Everyone said it exactly that way? Alex, go ahead.
For every 7 centimeters that the ramp rises, the run must be 100 centimeters.
Okay, so he used the words rise and run. That's perfectly okay. The only thing that concerns me about that is that I think your algebra teachers like forced in your head rise over run. And I'm not sure we all know what that means. Okay? So I'm perfectly okay, 100% high five, accept that answer. Don't leave me hanging, it's from Friday. Okay? So I agree with it, but do you know what rise and run means? So I think I actually, in a way, prefer Zara's answer, only because she used different words. But you're 100%. Great. Thank you for sharing. Anybody else want to share what they have? No? Kendall, read your answer. Okay, so she used run and height. So she used the same types of words again. Anybody have different words in run, height, rise, length? Okay, good enough. Let's talk about the middle stairwell versus stairwell 1. Okay, well, let's compare these two guys. What numbers did we get? Let's go ahead and, I think I have a page here. Yeah. Let's look at, let's do not the wheelchair ramp this time, but let's do stairwell 1 and middle stairwell. Okay? So I'm just going to ask your tables, because your tables measured together. Let's go ahead and see what we have. So this table, give me your answers for stairwell 1 and middle stairwell. The slope. Just give me the slope. 0.25? 0.55. And then middle stairwell? 0.53. Okay? Next. Oh, my Lord. Okay. All right, next table? Interesting. Zara's table? Middle, oh, wait, stairwell 1 first. Okay, and then middle stairwell? Oh, interesting. Okay. And? Okay. 100 your table? Exactly the same? You rounded to the nearest 2 decimal places. Perfect. All right, you guys? Okay. And then table 2, last but definitely not least. Oh, you're with them. Okay, same thing. What do you notice? Are they close to each other? Yes. Would you, so there was several groups that got exactly the same, right? And maybe like 100ths off or maybe, whatever. They might have rounded. Would we venture to say, I think 0.57 looks to be about the right slope, right? Okay. Is one steeper than the other? I hear some, what? What does that mean? Not really. Okay. And you kind of know that for a fact because they're the same height. They start at the same place, they end at the same place, right? So the slope's the same, the incline's the same. So it's got to be the same. Why does it feel steeper? Because it does. You guys feel like you go up that middle stairwell and you're like, oh, right? Why is that? It's more narrow. Stairwell 1's a lot wider, right? It's double. Like stairwell 1 is narrow, more crowded, right? That could be a reason. I'm just giving a hypothesis. I don't know. Any other reasons? Maybe there's more stairs in that one than there are in this one. I don't know. The stairs could be bigger and deeper, but the slope's the same. But maybe there's more stairs, so you feel like you're going up more. I don't know. All right, good questions. All right, so the last question that you guys had to write a sentence about was, are we in compliance? Okay, we were not 5 years ago. Okay, when I started doing this activity, we were not in compliance.
So are you the one that brought it up?
I'm not going to say that. I'm just saying that we were not in compliance. Okay, so we had to. So are we now? What was the slope? We said 0.07 or 7/100ths, right? And the rule, the law states 1 in 12. So here's the slope that we found, or we'll say 7/100ths if you want. Well, let's do it as a decimal for now. And then we have 1 in 12. And 1/12, I don't expect you to know that in the top of your head because we're not human calculators. But 1/12 is 0.083. Okay? So let's compare those two slopes. This is the one, this is the law, and this is the actual slope. Are we in compliance? Why? Go ahead.
It says we can't go over, there can't be more than 1 inch of rise.
Can't have a slope greater than, right? So is our slope less than the law? Which means our incline is not too steep. It's within regulations. Good job, SJHS. Okay? We got it. Doop, doop. We are within compliance. So hopefully that's a sentence that you wrote. Okay? If not, you should change it because it is. All right? So we are, in fact, in compliance. Our slope, we measured it. It is less than what the law dictates it should be. Okay? Cool. Excellent. All right, so let's talk a little bit more. We're going to come back to this guy. Well, let's move it so we can have it later. There we go. Let's talk about slope. Okay? Hopefully, today's notes are going to be slope of a line, okay, with today's date, just so you have them there. And you've seen this formula before, rise over run, delta y, delta x, and then you have this change in y over change in x. And those should really be subscripts. I don't like that they're not, so I think that's Mrs. Mackert going too fast and not actually making them subscripts, okay? Sorry about that. But y2 minus y1 over x2 minus x1. Do you guys know what x1, y1, x2, y2 are? We've done that before with the distance formula, right? So same thing. We're just trying to find the slope between 2 points. So if you have graph paper, you can use graph paper here, or you can just sketch it. That's totally fine, up to you. Please don't use the graph paper I gave you, because we're going to use that for something else in a minute. But let's find the slope. You can just use the formula. You don't have to graph it. It's totally okay. But hopefully we can label x1, y1, x2, y2, and we're going to find the slope. Notice the letter that we use for slope. Anyone take French in this class? There's a French word that begins with the letter M. It's the French word for slope. I think it's monter, M-O-N-T-E-R. Okay? So that means, I learned this a couple years ago because I actually had a French foreign exchange student. I didn't know that until 2 years ago, but now I do, so ha. Okay? But yes, why we use M is because it's a French word, and I'm not sure, I guess, I don't know, whatever, if that's the reason. The word that IB uses, or the international word for slope, is called gradient. Gradient. So I'm going to be using that word quite a bit as well. It is a word you need to recognize. When and if you go on to Algebra 2, further on into IB courses, math-wise, and science for that matter, gradient's the word that we use for slope. It's the international word. Okay? Us Americans, we only use slope. Let's find it. Okay? So, what am I going to do? Give me the numbers in my formula. Somebody who hasn't answered a question yet. You've answered 3 already today. So, Ali, give me the numbers. Tell me what I do. What do I write? Find the slope. I'm going to have a fraction. What over what? Give me the numbers.
-3 and
What goes on the top?
the y1,
So what would it be? Y2 minus y1.
so -2 and 1.
-2, what with 1? Add 1, minus 1. Okay, and at the bottom?
And 4 minus -3.
Okay. Would you agree with that? He plugged the numbers in. Perfect. Harriet, why aren't we writing this down, baby? That's not math. Okay, let's put it away. Thank you. Let's get out a piece of paper so we're prepared. All right, so when I subtract a negative, okay, we have a positive. And what is the slope we're going to have? -3/7. I'm here to tell you that negative can go with the numerator, it can go with the denominator, but it can go out front, but it cannot go with both. So I'm going to write that fraction all 3 ways, just so you recognize how it can be written. But all 3 of those mean the same thing. Okay? When we talk about the slope, we use the negative can go in the numerator, the denominator, and it tells us the direction we go from each point to point. So I'm just going to graph them for a minute. So -3, 1, and 4, -2. Okay? So if I wanted to just graph and count to find the slope, which we'll eventually do because we're going to be graphing the lines as well and writing equations of lines, which point do I start with? One on the left, the one on the right. It doesn't matter. I don't care. Find one that's your friend. I like the one on the left because I'm a quadrant 2 fan. I don't care, right? Whatever. So let's start with the one on the left. If I'm starting with the one on the left and I need to go to the one on the right, I'm going to do my vertical distance first because I'm worried about the rise. So I'm going to go down 1, 2, 3. Right? Down 3. That's where the -3 comes from. That means down 3. Now I'm going to move to the right 7. Right 7. Thank you, dear. Okay? So to the right 7. Down 3, right 7. What if I started with the other point? I would go up 3. Notice this is the fraction I'm using. Up 3, left 7. So that's why the negative can go on the top or the bottom. Why can't it go with both? A negative over a negative is a positive, which means then your slope would no longer be negative. It's got to go with one or the other. We can find slope. You did it last year. I think you did it in pre-algebra too, didn't you? It's like, enough's enough with this slope business, Miss Mackert. Really? Let's try a harder one. Okay? So I want us to look at some graph paper if you have it. And I want you to do this problem. I'm giving you a point, and I'm giving you a slope. We're building a little bit. It's a little bit different. I'm telling you what the slope is, and I want you to draw the line. So I want you to start with that point, and then I want you to draw the line that has that slope. Okay? We're eventually going to write the equation of this line, but for today we're just going to talk about the slope of it. Okay. I'm going to start at 4, -5. Now what? Wow, Asute. I asked someone this time. Go ahead, honey. Perfect, so tell me what I do. Okay, so the 2, because it's in the numerator, tells me I go up 2. Perfect, and then what? Okay, I absolutely love what he said. Up and right. I'm not sure what happened with the algebra teachers, but they always say up and over. Over doesn't tell me anything. Over can be this way. Over can be this way. Over can be this way. I'm going to go over here. Oh, I want to go over here. I have no idea what over is. Okay? Get that out of your head. It's up, down, left, or right, specific, right? And good job. So, do I need to keep going? I don't have to. Do I have a line already? Any 2 points make a line, right? So I have 2 points, I can draw it. If I wanted to establish a pattern, I could continue, but it's not necessary. Okay? We have our line. Hopefully yours is straighter than mine. Good. Eventually we'll write the equation, but not today. Yes, ma'am. We're going to get there. So you solved it, but I didn't ask you to solve it. I asked you to draw it, right? But you're on the right track because we're going to eventually be using that formula. It's called the point slope formula. Okay? Good. All right. Let's take it a little step further. Okay? So you guys have, if you would, go ahead. Bar Demetrius sitting right in front of me. Take this back out for me. Remember how I said we were going to skip the front? Okay, we're going to come back to it now. I just put them in opposite order, my bad. Let's look at the front. It has a circle with a slope on it. Here's where you need your graph paper that I gave you. Okay? So to get that graph paper out, and I want you to kind of follow the directions that are written on that page. I'm going to kind of go along with you for a moment. And I want you to, on your paper, make 2 distinct points anywhere on this piece of graph paper. I don't care where. Just make 2 points. Okay? I'm going to make mine with a Sharpie just so you can see them and we'll demonstrate and go together. But it doesn't really matter. Okay? 2 points. You good? So make your 2 points. I don't care. Anywhere on your paper. I always find it interesting that most people, when they make their 2 points, do it much like I did. I always want to see if somebody is going to be different. No, you're not different. I'm just looking. Not one person is different yet. Oh, yeah. Would you grab her once? Let me see. It's so funny. Everybody makes it this way. Why is that? Okay, that's all right. Everybody makes a negative slope when they do the graph. Everybody did. Everybody did. I do it too. I don't know what's in my brain that makes it happen, but we all did it, right? Isn't that weird? We all did it that way. I said make any 2 points you want on the paper. Last year I had someone do straight up like a vertical one. I was like, all right, thinker outside the boxer.
Can you try to do it? It's going to be different.
That would be awesome. I wish you would have. Then you would have got your glow pop. So you got to be different. Dare to be different. See, look at my poster in the back of the room. Individuality. Don't be afraid. It's okay. All right. I know. It's just, I don't know why. We all, most of us think this way. All right. Let's keep going now. Looking at the directions, it says, I want you to fold your paper so we create the line that's formed by our 2 points. I think it's easier to fold it on the outside so you can see the 2 points. And you want to kind of, I like to do this, make a little kind of a pinch right on the 2 points. I just kind of pinch the 2 points and then fold across the line. So, oh, my line didn't fold exactly. I'm going to try again. It's a little bit harder than it looks.
I got it.
But fold it all the way across. And I want you to actually darken this line. We're going to call this line 1. Okay, so go ahead and just, with your pencil, just darken it. And we're going to call it line 1. Okay, so this is my line 1. So just take your pencil and kind of darken it along the sides here. Okay, good. And I would call it, like, just make like L1 or something off to the side. This is line 1. Okay, but darken it and call it line 1. All right. Go ahead and find your slope of that line. So count and find your slope. And write it on your paper. Okay? So count. I'll do it too. Oh, here's something we have to do. We have to keep our paper and figure out which way was up. Because when you start turning it, it gets weird. So the hole punches should be on your left, okay? Mine doesn't have a hole punch, but I will. But we need to make sure we know which way is up. So the hole punch should be on your left. This way is up. We good? You counted? Write it on your paper. It says M equals, and there's a paper space right here. On here, there's a space for you to write what your slope is. Write it on there. I think it's on step 1. The slope of my line is. Write it on there. Leave it as a fraction, please. So leave it as a fraction. If it happens to be like -1/1 or -5/5, you can leave it one, like reduce your fraction.
Let's hope we just kind of let the boxes line up.
That's fine. But reduce it. Reduce your fraction, please, okay? Make sure you reduce it if it's not already reduced. What's the slope of your line, honey? Okay. Got your slope? Okay. We need to be following along with what we're doing. So we're here. I need you to count your slope and find it. I also need you to label that as line 1. Reduce your fraction. We write it as a, not a point. Write it as a ratio. Write it as a fraction. Good. Notice that you should have a negative number, right? Oh, you have a positive. Look at you, Jared. You're positive, and so are you, Jason. Here, I thought we all did it negative-wise. All right. You're positives. Okay, I just looked at it backwards. We're good. All right. Only if you are vertical or horizontal. All right. Only if you're vertical or horizontal. All right, ready? You wrote your slope down? Okay, good. Be careful. Some of you are positive, some of you are negative, actually. So that's fine. All right, the next step tells us to fold the paper so that the 2 points meet. So here we go. Take your paper. It's going to be easier to hold it up to the light. And you want to fold it so that one point is exactly on top of each other. You might need to darken your points pretty dark so you can see them through. That's why I used a Sharpie. But you want to kind of darken them enough so you can see them and they fold one right on top of the other. And I want you to fold that line. And we're going to call that line line 2. Make your points big and dark if you need to so you can see that they fold one right on top of the other.
Oh my goodness, I never did not want to.
Put it right up to the light because it makes you can kind of see the paper through it. Hold it right up to an actual light box. And then you have another line, and I'd like for you to call that one, don't darken it now, but call it line 2. So we have line 1 and we have line 2. Okay? Line 1, line 2. I would like for you, okay, to tell me what you notice about what they look like to you.
Like the intersection points, like the midpoint.
Definitely not on mine, right? but that's the way you happen to draw it. So it's a good observation on your paper. I totally agree. Is there anything else that you could notice about all of our paper folds? They looks like they're perpendicular. Okay, I agree with that. It does. And in fact, line 1 is perpendicular to line 2. Go ahead and write that. It says, what do you notice about the two folds? So on number 2 on your paper, what do you notice? They're perpendicular. So go ahead and write that for me. Line 1 and line 2 are perpendicular. Okay. So let's find 2 points on line 2. We don't have 2 points, but you're going to have to look at how you folded it. Make sure it's exactly, find a couple of exact points, and find the slope of that given line. So I'm going to pause this for a minute, and I want you guys to find 2 exact points and find the slope of line 2. I'm going to go around the room, and I'm going to ask you to tell me your slopes for line 1 and line 2 right now. Are we ready? Okay? All right. All right. Asia, what's your slope for line 1? What's your slope for line 2? Okay, and line 2? Okay. I'm going to use a different color, so I don't think you can see that very well. So you said negative 7 over 4 and 4 over 7? Okay. Taylor, line 1. And line 2? I'll come back to you. Okay. Neha, line 1? 4 over negative 5. Okay. And your line 2? Can you reduce 10 over 8 for me? Okay, good. All right. Manuel.
2/3.
2/3 and?
Negative 3 seconds.
Huh. Interesting patterns going on here. Dina, line 1? I'm sorry? 1/2 and line 2? No. Go ahead and count again. Make sure you're doing rise over run in both cases. Let's look at the pattern that we have. Taylor, did you find yours, honey? Okay, that sounds not negative. It should be positive. One should be positive, one should be negative. Okay, good. All right, so let's just look at these 4 for a little bit. Okay, Stephanie, want to give me yours? Go ahead. Negative 2/3 and positive 3 over 2. All right, there is a pattern between all of these slopes. What do you notice? If one is negative, the other one has to be what? Positive. And what else do you notice? Use a math word here. Hang on. It's all right. Harriet, go ahead. That's not the math term I'm looking for, but I know people want to call it the inverse, but the actual math term is reciprocal, okay? The reciprocal means that the numerator and denominator are flipped. Inverse actually means something else mathematically, believe it or not. It means the x and the y are switched. It means that they're inverse functions. Anyway, it's okay. Reciprocal, all right? So they're opposite reciprocals. You probably have heard that. Opposite means the signs are opposite. Reciprocal means numerator and denominator are switched. That always happens for perpendicular slopes. So I want us to write that. I think there's a space for us to somewhere. I believe. Hopefully there is. Okay. Number 8. There's 2 lines on number 8. The first line, I want you to write a summary sentence about perpendicular slopes. So what's true about perpendicular lines? So back to our paper folding. We're going to make a 3rd line now. Okay? We're going to make a 3rd line. You ready? So let's keep following our directions here. The directions say, we're on step 5, just so you know. Okay, so look at step 5. Okay? It says fold the paper along the darker line. I'm going to do it here so it's showing. Okay, so my darker line is on the outside of my fold. Okay? Fold your paper along the darker line, which is line 1. Your 2 points should be showing. And then it says fold the paper again so line 2 meets itself. Miss Mackert, I have no idea what you're talking about. Okay, nope. Watch, nope. Watch, nope. Don't fold it without it me showing you. You ready? Do you see that you have a fold that's here? That is line 2. Do you see that? Okay. You are going to fold this again in this direction so that it meets itself on the fold. So, you're going to do this. Okay? You're going to fold your line so that the fold meets itself again. You want this to be one continuous line. Yes. You want one continuous fold. So here's my original. I folded it over so that this line meets this line. Okay? I'm going to show you again. So look right here. So you have here, this is my line. I'm going to fold it so that this meets here, line it up, and fold it. Yes? Okay, you good? So here, watch. Farouk, you don't need this anymore. So here's our original. See this is line 2, right? I'm going to fold it so that line 2 folds in on itself. Okay? So I'm going to watch it. Yes. Yes. Good. All right. Now I created a couple of different lines. I think I created lines 3 and 4. Yeah. Open your paper up. It should look similar to mine. Similar, okay? Yes, ma'am. I'll give it to you just 1 second. Folds. Shh. What about lines 1 and lines 3 and 4? What do you think they are? Somebody besides Alex. I know Alex knows. Carrington, what do you notice about all 3 of these lines? What are they? They're parallel. Okay? So I agree. Lines 1 and 3 are parallel. Would you look at the notation I'm using for that? The 2 little lines that go like this mean parallel, okay? And then lines 1 and 2 are going to be perpendicular. Do you agree with that? Okay? That should be how your paper folded too. I want the same people now who I have written up here to give me the slope of their line 3. So try and remember who you are. Who had the 4/7? Okay, Asia, what'd you get for line 3? You should have got -7 over 3, probably because of a little fold. What do you think it should be? -7 over what? Okay, yeah. All right, how about -6/7? Taylor? Okay, and how about the 5/4 person? Who is that? Okay, what'd you get? Yes. Okay, I'm going to write that here, and we'll look at it, okay? 2/3, -3/2. Who is that? You got 2/3 again? Okay. You should get positive. Because if they're parallel, they should have the same direction, right? Okay, it should be negative over negative, maybe. All right, how about the last one? What should it be? -2/3. So what are you noticing about lines 1 and lines 3? They have the what? The exact same slope. Now, these 2 might be a little bit off because I'm not really sure. Maybe just the folding wasn't exactly or whatever. That's okay. But we should have a pattern here. So I want you to write your summary sentence at the bottom now on line 2 of number 8. Okay, so number 8, line 2. You had one sentence. If you just write underneath it if you want to. If you don't have room, it's fine. Okay, so you're going to write on the second line, write a sentence about parallel lines. What is true about parallel lines? They have the same what? Slope. So parallel lines should have the same slope. Perpendicular lines should have opposite reciprocal slopes. Okay? Opposite sign and reciprocal. Okay, good enough. So if you would now, let's apply what we just learned. You probably already knew this, didn't you, from algebra? But let's go ahead and look at the next page. Can you do that for me? Where we have two different problems. And I want us to go ahead and answer these two questions. So I'm going to pause the recording for a minute. I want you to look at this 6th Street, Ford Street, Clover Street, B Street problem, and then the one right underneath it, okay? Okay, are we ready? Looks to me like we have an answer. All right, so we don't have a coordinate grid, right, Brian? We just have these street names, and we're told some slope of one of the streets. And we're really kind of asked some questions here about finding all the other slopes, right? So we are told that we have two pairs of parallel lines. So Courtney, if I look at that, which lines appear to be parallel, or which ones would be parallel here? What's parallel to Ford? Okay, and then what are the other two would be? Clover and B, and those would be parallel as well. Okay, so knowing that our slope is -3 for Ford Street, and knowing what we know about parallel lines now, what's the slope of 6th Street? -3. They have to have exactly the same slope, right? All right, and then how about Clover Street? What do you think about Clover Street, Sophia? What would the slope of Clover Street be? Knowing that 6 and Clover are perpendicular to one another. Positive 1/3, excellent. And if Clover and B Street are parallel, which they are, what's the slope of B Street? 1/3 as well. Okay, so not really a trick question, but more or less, can you apply what you know? All right, and then the last question, we says, which 2 points determine a line perpendicular to a given one? What did you get for that, Alejandra? Second question. You don't know? A, B, C, or D? Did you not do the second problem down the bottom? Okay, Jerry, did you do the one?
Yeah.
What'd you get? D. Okay, did you get D? Do you know how to answer that question? All right, so let me go ahead and pull it up here. And let's look at it. Woo, that was fun. So we are given -3, 6 and 2, 5. And we have the line drawn through those. What's the slope of this line? How do I find it? We'll call it line 1. The slope would be, so we're going to have, you said 5 minus 6 over 2 minus a -3, or -1 over 5. I agree. So it says I want to figure out which pair would be perpendicular. So you can use the graph if you want, or I could just use the formula. So let's check Jared's answer out. Let's make sure that he chose the right pair. So if I'm going to find the slope of the perpendicular, we're hoping that these 2 points work. So if you look at answer choice D, it's going to be 3 minus 1 over -2 minus 3. So I have 2 over -5. Close, but exactly? Probably not D. Would you agree? So why don't you check A, B, and C and figure out which one is the correct answer?
We'll make one out.
So so we have some issues. So I think A, when you found the slope for A, you got positive 1/5. Did you get that? Because that's what I got too. Now, that's neither parallel or perpendicular because it has opposite sign as -1/5, but they're not reciprocals. So A can be crossed off. What's the slope of B? I got 2/4 or 1/2. Again, not opposite reciprocals, so cross off B. If you look at C, I get, I got -3 over -1, or just 3. Again, we're looking for it to be 5, aren't we? So D is probably, well, no, because they're not reciprocals either. C would be the closest, but I agree with you. I don't think any of those work. So we should probably cross all of them off. And why don't you make up one yourself? That does work. Create 2 points that would be perpendicular. So let's see what they would be. Let me get you started. Well, I'll let you go ahead. Create 2 points that would be perpendicular. The slope of your 2 points that you chose should be positive 5/1. Okay? So just double check and verify that the slope of the 2 points that you picked is 5/1. Positive 5/1. So Dina, give me the 2 points that you chose. Kira, can you?
Wait, miss. Couldn't it be 1 over negative 1?
No, because 1 over negative 5 would be the exact same slope and they would be parallel. All right, sorry, Dina. Did you give me 2 points, babe? Yeah, you're the only Dina in here. Shh, 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 shh. What 2 points did you pick? I couldn't hear you. I'm sorry. Oh, anybody get one that worked?
Yeah.
Go ahead.
Negative 1, 1.
Okay. And 4, 2. All right, let's verify. We want it to be, the slope to be 5/1, right? So 2 minus 1, and then 4 minus a negative 1. That's 1/5, not 5/1. So I disagree with this answer. Anyone want to try and get 5/1? Kendall. Shh. 2, 4, and excuse me, folks. And 1 what, baby? 1 negative 4? Negative 1. All right, so we have negative 1 minus 4. Negative 1 minus 4, and then 1 minus 2. So negative 5 over negative 1, positive 5. Hallelujah. Hallelujah. Yes, we got it. 2 points. These 2 points would determine a line that would be perpendicular. Guess what, folks? This is an SOL question. And Kendall, so far, has a 600. Come on, girl. Boop, boop. Got it. All right? So let me show you how the question could be written. It's not going to be written this way, but it'll be written a different way. So let me show you how it's going to be written. Okay? You know on your algebra SOL where you had the little pointer, you could click on the graph? Remember that? That's the kind of question you're going to have again. Here's how the question should be written. Please put it in your notes. Okay, last thing you're going to put in your notes for today. Plot a point that passes through the given point and is, it could be parallel or perpendicular. So I'm going to highlight the word that might be different. It could be parallel or perpendicular here. It doesn't matter. You should be able to do both. But we're going to do parallel today. So copy this on down. So I wrote the coordinates down just for ease of your repeat graph so you can actually see what they are. The coordinates would not be given to you on the SOL, so you need to recognize that, okay? So those are only there for you so you can see in the back and know exactly where the points were. That's it. Okay? How many different possible answers are there? Is there only one? Can you plot the point that's going to make the line parallel? Everyone think about this question. How many different possible answers are there? Sharon? There really are an infinite amount of answers. But because we only have this like a little snapshot of the coordinate plane, there's only a few possible answers that will fit on the graph we have, right? So let's think about what one of the possible answers would be. Now, before we start actually plotting the point, what do you think we should do first? Find the slope, okay? Find the slope of the line that we're given. Baruch, what's the slope of the line that we're given? Six minus 3 over 6 minus 3 over, keep going, honey. What's the slope formula? So tell me what numbers I write. Just tell me the numbers I write. Don't try to solve it. 6 minus 3 over what minus what? Very good. And I'm going to go ahead and make it a plus 4 because when you subtract the negative, it becomes positive. When I reduce this, I get 3 over 2, right? So what do I want my slope to be if it's going to be parallel? Parallel. Parallel means they have the same slope, right? If this word was perpendicular, then I would agree. The slope we'd want to use would be negative 2/3. So that's the key word. Is it parallel or is it perpendicular? I want it to be the exact same. So my new point, there's a couple of different things I could do. I could go up 3, right 2. That's one possible answer. So on the SOL, if you have your arrow, you can plot the point right there. I could also, make sure I did that right. Yep, I could also go 1, 2, 3. I could also pick that point. I could pick that point. Could I pick some points down on the left-hand side? I could go down 3, left 2. Any of these possible, any of those lines are possible, any of those points are possible answers. Okay? All right, let me give you your homework. It's going to be out of your textbook today, okay, for the weekend. So on pages 201 to 203 in your book, it's going to kind of jump around a little bit. I want you to do problems 8, 10, 16, and 18. And then I want you to do 24 and 26. I'm just going to have you do 24. And I'm going to have you do 36. And we'll try, actually we'll do 30 and 36. Now, and there are 2 problems that say write the equation in slope-intercept form. Please realize what they mean is this. Okay? We haven't gotten to equations yet, but you know what slope-intercept form is, right? All right. So there's your homework. It's not that many problems. Problem 30 is a little bit more entailed than you think.